Hey, welcome back. This is week 4 of Prepping Data Challenges in 2023. So yeah, this is a big one. This is where we have to go and combine 12 different tables together. So we have an output here that I've already gone uploaded to Snowflake. All my tables for each individual month. I'm going to go and union these all together. There's not quite such an easy way to do this in SQL. Here, it gives you nice solutions of like wildcard unions. This works for stuff like Tableau Prep and Ultrix, but for SQL, it's going to be a bit of a grim stage of just unioning everything together. But I do want to mention some important points. So typically you may think, oh, I would just go union. I've got my one table here. I'm just going to go and select my next table then as well. So yeah, so I could go and union April and August together. SQL is doing something here that you probably don't expect. So after a union, it will make a distinct of the result that you're seeing here. Okay, so you join me on this query pane. So if you're in Snowflake, you can go into activity in your query history. If you click into a query, you'll get the details, but you also get the profile here. So this will tell you what's happening with your query. Okay, so this was the one I just ran where I'm unioning two tables together. So what it will do first is it will find these two tables, scan them, and then do a union all. In this case, so this will union them all together, and then it will do this. It will aggregate your values together. So as I mentioned, it will run that distinct clause over it, and then it will return your solution to the query pane. Okay, so let's change that. Let's go and just do a union all because we don't want to deduplicate these results, not just yet. You can imagine if you wanted to sum some sales of products, you then will start losing records. Your totals will be invalid or wrong. Okay, so if I go change this to union all. Okay, so this is my query now with that union all. So you can see that aggregate step, that distinct deduplicate everything is gone. So in most cases where you're just stacking data together, use union all. Okay, back to the task. As I say, there's not quite an easy way of doing this other than just writing them all out, which I'm going to go and do at super speed. Okay, so I've gone and written out my union for all my different tables. In practice, you probably wouldn't do this, right? You'd probably just make one table based on 1 month and then insert all the other tables into that and just not have so many tables cluttering up your workspace. But we'll go with this one for now. So I'm going to go and run this. It's all come back all good. So I've got all my data coming back here. Okay, so this condition here. Some of the fields are matching up as we'd expect due to differences in spelling, merge these fields together. So what will happen is that SQL will just take the first set of columns from your first table as your column headers. Everything else will just be filled in behind that. Say if you had a table that then had, say, an extra column, yeah, you'll get certain things like this. So you're going to ever come back and say, hey, you've only got to have consistent columns all the way through. So you can't have things like this and it won't be like merged in nicely or anything like that. Yeah. If you have that case where you had, say, this case where there was an important piece of data that needs to be brought in from this file, you would then have to just go and add that extra column to all your other sections. So go null as test. You'd have to do that to every other table just to make sure the columns were consistent or like had the consistent number of columns in them. But thankfully, all our columns are all good. That's all come back, so we don't need to worry about differences in spelling in this case. So that's okay. Make a join date based on the joining day and the table name. Okay. Another pain point: we can't bring in this table name in a very like nice way. So guess what? I'm going to have to go and make a column for that includes that table name and bring all of that in. So be with you in a sec. Okay, so I'm going to keep it authentic to the challenge. I'm going to put in the full table name. Okay, so I've gone out of that table name column in there, so I want to go and make this joining date based on the joining day, the table names, and the year. I'm not going to do this in every query because that would be quite tedious. So what I'm going to do is convert this to a common table expression, and then I can go and manipulate all the fields all together in one query. Okay, so all my data is coming back in the same format. Let me just go and spell out the different columns. Okay, so what I'm going to need to do is do a bit of date from parts, but I'm going to need to get my January back here. So what I'm going to do is kind of use that cheeky split function we've seen a few times. So split parts. In this case, I want the last part. So I want to split that column. Okay, so I've got my month passed out here. I now need to convert it to a date because it's just a string at the moment. And if I can convert it to a date, then I can convert it into the month number for my dates to part. So again, if I remember earlier in task 1, we went and converted a date. Go and convert this to say that this format is a month, like a full month name, which is these 4 M's you can see here. That will then go and convert this to a date starting in 1970. So let's pull out that month there. So yeah, you can see here that the month increments here, but nothing else. And then from this, I can pull out the date underscore part, take a string, convert it to a date, take the date, convert it back to a number. So a bit of a few steps to get there, but now I've got a month, I've got my day, and now I can do my dates from parts. So I can do, hey, so I'm going to take my, so year, month, day. So I'm going to take 2023, take this is my month, this, and then my joining date. Call this as joining. That looks good. Okay, so now we want to reshape our data so we have a field for each demographic for each new customer. Basically what they wanted us to do is go and pivot this. So change date of birth, account type, and ethnicity, turn these into columns for each of these customer IDs by the joining date. Okay, so we can do this. We will do a pivot in this case. So get rid of these extra columns. So this is just what we need to be working with. Okay, so similar to our unpivot before, we're going to need to add in an extra field after our table and go pivot, and go bracket. So we want those values, value for our demographics, and we want those in these different demographics here. So ethnicity, account type, and date of birth. Okay, let's run that. Okay, so I've got this issue about unexpected demographic. Because this is because, okay, so I'm looking for my values in my demographic, and this is the columns I want to bring out. Select statement doesn't really reflect that. I need to have my columns for ethnicity, account type, and date of birth there. I've also got to go and tell SQL that those are going to be my columns because it's quite challenging for SQL to understand that what account type is with this space going on. So there's going to be some steps here that will go and fix these issues. We also know from the introduction that the value may have multiple values. So in this case, I just want to take the maximum value just to overcome this. And so I need to also go and account for the rest of what's going on here. Yes, so it's going to complain what's demographic in this case. It wants it to be these different columns. So it wants it to be ethnicity, date of birth. So yeah, so it wants my different columns there. Then going to run into an issue, so it doesn't really understand what ethnicity is meant to be here when it's trying to fit the data in here. So we need to go and specify what our output columns are going to be. So we do this here. So I'm going to give this my alias as P. So I'm going to call this pivot as P. and it's going to consist of the order columns I've got here. Run that. Okay, nope. But let's see if this works without the joining date. So if I go and comment this out, and then go comment it out from my query, so that works to a point. Bringing in an account type here, which I don't quite understand. Never mind. What I'm going to do is I'm going to rejig this a bit just so I have the columns I definitely need before doing this pivot. Call this pre-pivot. Cool. So this is what we want to be working with when we do our pivot. So we want to keep these two columns and then pivot the rest. Okay, so let's go and work that back into what we had before. Uncomment all of this. So date from parts, that will just now be joining date as we have above. Fine. Select from pre-pivot here. Okay, that. Then we can bring back in joining date here. Give this a run. It's matched between the number of columns produced. Oh yeah, because you won't need a column for value. With that. Yeah, we won't need value anymore because value is going to be in those different columns. It's a bit of a sort of complicated syntax to sort of work for. I mean, always with these cases, sort of try and get it as simple as possible to then sort of work out how to do this pivot for your different columns. See, even here, we're able to use a common table expression to keep that function at one side while we were able to do the pivot here because that wasn't working before. But now it does work, which is great. Yay, so we've done this. We want to make sure the data types are correct for each field. We want to remove any duplicates. If a customer appears multiple times, take their earliest joining date. Okay, so for date of birth, we want to convert this to a date. Count type, that's fine, that's fine, that's a date. ID, that's looks like a number in this case, yeah, because it's right-hand justified. Okay, so we want to also try and work out these accounts that have come back multiple times. So what I'm going to do here for this case is find a column called row number. You need to say what it's over and say whether you want to partition it by certain columns. We want to say every row will start again at a customer ID. And then we want to order it by the joining date. Yeah, so I've done order joining date. I need to do order by joining date. I'm going to give this an alias as rn. Okay, so that looks like that is working. The only trouble is you can't query this rn because it's a like window operation. So if you want to go and say find me all the row numbers there too, you'd go and have to make another common table expression, which I'm going to call post pivot. So we found one there. So this is one case where we have a duplicate record. We only want to keep those with the earliest record in these cases. So I'm going to change that back. And I'm going to go and tidy this up for an output. Okay, pretty lengthy one. Okay, that's been week 4. Join me next time in week 5.